gender bias. Let's see, cosine minus negative cosine of 0. That's one term. And then I'm going to go minus, and this is going to be negative cosine of 2 pi minus negative cosine of pi. And then now we just go easy. Sorry, I'm going to fade a little bit on this. But let's see, what's the cosine of pi again? Cosine of pi, what is it? Cosine of pi is -1. So I'm going to get negative, -1. These two negatives become a plus, +1, right? Minus cosine of 2 pi is +1. So I got -1 plus, because this negative, cosine of pi is -1. Do you agree with that? And I end up with 2 minus -2, which is affectionately known as 4. The area between sine x and the x-axis is actually 4. All right? That's pretty cool. Check it out. All right, now let's put this idea about positive and negative quote-unquote areas into effect. Let me write up a problem with it. All right, suppose that v of t equals t squared minus t minus 6. Okay? Now, I'm going to come up with, I want to know that this velocity describes the behavior of a particle. All right? And let's say that we're interested in figuring out what happens between, say, t equals 1 and t equals 4. All right, so this is on the interval from t equals 1 to t equals 4. I want to know, if I know the velocity of the particle, I want to know what is the displacement of the particle. What is the displacement of the particle on closed interval from 1 to 4? And B, what is the distance traveled? Distance traveled on closed interval from 1 to 4. All right, now let's have a quick little discussion about the difference between displacement and distance. All right, let's say that my particle started here at t equals 1, and it starts moving right. But then somewhere between 1 and 4, I don't know, let's say at t equals 2, the particle stops and it chooses to head backwards, and then it stops right here at, say, t equals 4. All right, I have no idea if this is the behavior of the particle, but I'm just playing. Think about it. It's actually very simple in terms of the distance between, or the difference between displacement and distance. Displacement is simply the distance between where the particle started and where it stopped. So this guy right here is displacement. All right, it's basically a point. Think of it as it's the distance with reference to where it started versus where it stopped. Now, if I want the distance, we got to take into consideration the fact that the particle moved right from t equals 1 to t equals 2, and then it moved left. So if this is d1 and this is d2, then the total distance traveled is going to equal that distance from 1 to 2 plus the distance from 2 to 4, which I'm calling d2. All right? So we already know the relationship between velocity and displacement, right? The derivative of displacement is velocity. So if I want to get from velocity back to displacement, then I have to take an antiderivative. But before we take an antiderivative, let's take a look at velocity. All right, I know what I'm interested in is, when does this thing change directions? So think about that. When does a particle, what does the velocity tell us about a particle when it changes directions? In other words, what information does velocity give us? Well, if a particle changes directions, it's got to stop first, right? And if it's got to stop, its velocity is 0, right? So that's really what I'm interested in. This is begging to be factored, so I'm going to factor it. I get t plus 2, t minus 3 equals 0. So I know, since this is a derivative, remember, velocity is the derivative of displacement or of distance in certain contexts, which we'll talk about here in a little bit, then I'm going to get critical points at t equals -2 and +3. But remember, we're on the closed interval from 1 to 4, so this guy isn't even on our radar. Now, if I throw this onto a Ripley-Doodle diagram, here's 1, here's 4, and here's 3, now I can test to see what the thing's doing. Well, let's see. If I grab a value between 1 and 3, 2 seems like a prime candidate. If I plug it into here, I get a negative. If I plug it into here, I get a positive. Negative times a positive is negative. If I put 3.5 in and I plug it into t minus 3, I get positive, positive, I get positive. Oh, it looks as though this particle from 1 to 3 goes left, it stops, and then it goes right. Now, if we think about what v of t looks like, I know it's parabolic, right? So I know that at t, if this is 1 and this is 4, then somewhere about here is 3. This guy's parabolic. So it's going to look kind of, badly drawn. It's going to look kind of like that from 1 to 4. So this is v of t. So if I'm going to discover the displacement of this thing, I can simply integrate v of t from 1 to 4. If I do the integral of v of t from 1 to 4, don't forget your dt, you got to have your width of your subinterval. Won't this give me the displacement? Because it'll add up all this negative stuff, and it'll tell me how far left it traveled, and then it'll add up the positive stuff, and it'll tell me how far right it traveled, and those two will cancel out, and it'll tell me where it ended up with respect to where I started. So let's do that. Well, this is going to be the integral from 1 to 4 of t squared minus t minus 6 dt, right? And this is just going to end up being t cubed thirds minus t squared halves minus 6t from 1 to 4. And this is going to be 4 cubed thirds minus 4 squared halves. I know I'm doing it the long way. Just give me a break, would you? That's 4. And then minus, just so you see it. It's not a bad idea to see it. And then this you can cheat a little bit on. We can go 1/3 minus 1/2 minus 6. Right? Now, we're just begging to use a calculator here. Let's pull out our handy dandy calculator. And here it is. And let's see, I'm going to go parenthesis, and let's see, 4 cubed is 64, right? So I'm going to go 64 divided by 3 minus 16 halves is 8 minus 24. And I'll do it in paren, and I'm going to go minus, and then I'm going to go paren, and I'm going to go, what, 1/3, 1 divided by 3 minus 1 divided by 2. I guess I could throw a 0.5 in there too if I wanted to. And then what is that, minus 6? Minus 6, and I hit this, and I enter. What do I get? Negative 4.5. If I want to get crafty and turn this thing into a fraction, I hit enter, and I get negative 9/2. Sweet. Negative 9/2. That means if I started right here, I don't know where I'm starting. If I'm starting at some point in space at t equals 1, by the time I'm done, I will end up to the left negative 4.5 units when I stop at t equals 4. That's just displacement. Now, all kinds of craziness could have happened in here. Actually, it couldn't do that because we know it only changed directions once. All right? Now, let's bring that back into play. How about if I take the distance? Well, what am I going to have to do? I'm going to have to acknowledge that this thing moved left from 1 to 3. So as far as my point of reference is concerned, I'm going to get negative values because the heights of all these little rectangles right in here are going to be negative. Right? This is a little sliver of action, which I refer to this as action. And it's the height of the rectangle. So here we go. I'm going to integrate from 1 to 3 v of t dt. But because I know it's negative, I can either put absolute values around the whole thing, or I can just slap a negative on. Right? And then what am I going to do? Well, I'm going to integrate from 3 to 4 v of t dt, right? But because it's positive, and distances are always positive, much like area is always positive in a geometric context, right? That's the reason we slap this negative on here, because I want my distance to be positive. But this guy's already positive. I'm just going to add it. All right? So let's do this really quickly. And then I'm going to show you a fabulous trick on your calculator right here. You'll love it. This ends up being negative. Here we go. We already know what our antiderivative is, right? Our antiderivative is sitting right here for us. It's going to be t cubed thirds minus t squared halves minus 6t. Now I got to be real careful here. I want that negative to be out in front. I don't want it just attached to the t cubed thirds. This is evaluated from 1 to 3, and then plus, and here we go. I'm going to go t cubed thirds minus t squared halves minus 6t, and this is going to be from 3 to 4. Okay? And we could do this whole thing out by hand if we wanted to. But I'm going to show you how to use your calculator. It's time. All right? I want you to have the ability to check your work using technology. I'm going to take the integral from 1 to 3 of v of t dt. All right? But I'm going to stick a negative in front of it. I'll do that after. Okay? So here we go. You ready? I'm going to go to math. I'm going to scroll down until I hit something that looks like an integral. By now, I've already shown you how to use your calculator. Whoops, I got a little jiggy with that, didn't I? Sorry, guys. So apparently, it was easier to go up. I'm going to go up to FNINT. That means function integral. All right? And look at this. It's already in place. Now, for those of you that don't have the new OS, this might be a bit of a pain in the butt. I can show you how to do it. It's not very hard, really. So I'm going to go 1 to 3. And then I'm going to cruise over here, and I got to do what? I've got to stick in my integral of t squared minus t minus 6. So this is going to be x squared minus x minus 6, right? And that's going to give me, and then I'm going to go dx, and I'll explain why you have to put the dx in there in a little bit. And I got to go 1 to 3, and booyah. So this value right here ends up being, whoa, didn't want to do that. This value right here ends up equaling, I've got a negative in front, right? So if I change the sign, this is going to equal positive 7 1/3 last I checked, right? Now I'm going to take the integral from, where are we going? We got to go from 3 to 4. So I'm going to go second entry. It gives me exactly the same thing, only now I get to go back and change my limit. Here we go. Sorry, you guys. So this is going to be from, I'll put a 4 in there. This is going to be a 3, from 3 to 4, extra booyakasha. And I'm going to add 2.833. Wait a second. I don't know what 2.833 is. I wonder if there's a way to turn this into a, oh yeah, there is. And I just hit that. So look at that. That's 12. That's 17/6. So let's see. 7 1/3 is 22/3, right? This is 22/3 plus 17/6. If I add that, I have common denominator 6. So what is that? 44 plus 17 is 61/6. 61/6. And that is the total distance that it traveled in its meandering path. Isn't that cool? Oh, let's do this guy to make sure that we got it right. Oh, did I write -9 here? Wasn't that supposed to be -9/2? Yeah, sorry. I don't know why I didn't do my 2. All right, let's double check this guy just to get you in the habit. You guys know the trick about I can hit second entry and keep hitting it and it'll bring up, oh, look at that. If I take the integral from 1 to 4, so I just got to play here a little bit. I've got my 4 there, and I go from 1 to 4, it better be -4.5, right? If I hit enter, yay, there it is. Isn't that awesome? So I've got displacement here. I've got distance here. Now, unfortunately, on the AP exam, they could give you a problem like this where you can't use your calculator. So like I've always said, a calculator can be used as a tool or it can be used as a crutch. And if you're using it as a crutch, guess what? It's going to get kicked out from under you. So you have to be able to do these things by hand as well. Okay? I hope that was useful. I hope it was kind of fun for you. We're going to do a bunch of these in class. Thank you for your time and your attention. And I'll see you tomorrow.